Okay, welcome. Now it's time for the first session for today. So please welcome Baruch Sadgurski.
Thank you, Andres. Good morning. Thank you all for coming. Last day of JFokus. How was it so far? Woo! Morning, I know. I'll do my best to wake you up. It's going to be even better today, trust me. Or don't trust me. Because, we have a trust problem. How many of you use AI to help them write code? Keep the hands up. Like about 90%, right? Now, keep the hands up. Now, keep the hands up whoever use AI agents to write the code for them. Still a lot, probably 50%. Cool. Who is happy with the results? 5 hands? Yeah, that's what I thought. That's me last night, coding with my buddy Claude. I'm very happy so far. It did some amazing work. Coded for 4 hours, crunched almost 25,000 lines of code, tons of tests, very impressive code coverage. All the tests pass. I don't care about the last line. The employer pays it. Now let's see the app. Who can relate? Whoever uses the agent can relate. So that was me. And then I go to Git, I go to see what's going on, and basically this is what I see. Right, I see some very relatable chuckles. This is because we have what I call intent to code cover. We want to get something, and we ask for it, and then eventually we get something that is completely different. Not working at all, maybe working not the way we intended, maybe working almost as we intended, not the way as intended, but never what we actually want. And that's because we have a problem of trust. And we should never trust a monkey. We're going to talk about the chasm, the craft, and the chain of assisted code. And your feeling that AI is not doing exactly what we asked it to do is actually backed with science. And every time you see a screenshot from an archive, you know that it's science, because it's studies and stuff. So this is science. This is a relatively old one, 2023 research. There was one on different models, and basically the bottom line is about 50% of the code that it generates is incorrect. And you can say, well, 2023, it's last century, it's like horses with carriages. Now it's much better. Well, not so much. This is another research from Sonar, and this is just a couple of months old. And this is much more interesting, because what we're saying here is that all these benchmarks that Sonar, their job is to assess the real quality of software after it has been written. So what it says here, that the first thing is no explanation between the model's functional performance benchmarks and what's not, and the actual quality of code, which is defined. Another study, this was from Coda, that does AI quality assurance stuff, and they have both in the exploration. So, hallucination frequency versus confidence in shipping AI code. Only less than 4% believe that their models are not hallucinating and they're good with shipping it with confidence. We, all of us, are in the 76% that believe that models are hallucinating a lot and we shouldn't really trust them. And this is also very recent. And we don't trust them. 25 Stack Overflow Developer Survey. Well, this one is biased. The 5 people that are still on Stack Overflow hate AI with passion, right? Because they stole all their correct and incorrect answers. But regardless, this is disturbing. Again, 3%, 3% by the way, highly trust models. More than half do not. And that's again, very close to what other models or other surveys find. Another very cool company, AirLaw, they do security stuff around APIs. And you can see like a very disturbing beginning of a hockey stick that skyrockets. What is it? APIs with missing it with validation, like at all, and authorization at all, over the internet, like over the entire world, because they were vibe coded and just left it there and no one actually checked. So this is fascinating. We're going to solve this today, right now. My name is Baruch Sadugurski. I'm a JBaruch on the internets, a member of the real silent company called Temple. We will see how it relates to all of that. I've covered books about Java and DevOps, Java Champion, and Microsoft MVP for AI. And the most important slide of this talk is this. So if you scan this QR code or go to speaking.jbaruch, you will find the slides already uploaded, the video that I'm recording right now, and most importantly, all the links to everything that we are going to mention today, including the research, but not only, already there. It's convenient together with the hashtag intent integrity chain that, thanks to your sharing on social media, going to be trended in 2 hours, and I will check. And JFokus, which probably already is, and JBaruch, as I said. Okay, so models are getting better. It's always up and to the right. This is one of those benchmarks, and you can see here clearly the, up and to the right, always up and to the right. It's getting better in writing code. Very impressive, we're all very happy, but in the end of the day, well, nothing really changes. The AI-generated code is still not great. If you ask it to build an app, it will usually all be controlled running in CI flow, and it will have some unprotected API that doesn't have any authorization or input validation, this kind of stuff. To understand why, we need to go back to the source of software, where the software starts. And software starts with what is called PRDs or software design documents, depends on what you are. And this is basically a text document that product people and with the input from business people and sometimes from others write, and usually write it once. And someone might read it on the R&D, or might skim it, or might not read it at all, and write a code based on what they understood. Why does it happen? There are a couple of reasons, and I'm going to try a joke in Swedish, and I need to know if it lands. So one guy asks the other, like, says, "We lost him. What happened?" It did! Yay! So, if there is anyone else who doesn't speak Swedish, I'll try to explain. Gift is both marriage and poison. Alright, yes, success. Try to do it in different languages in every country. Sometimes it's a hit and miss. Okay, so the point is that even when we speak the same language, we only think we speak the same language. There are a lot of misunderstandings, most of them naive and not because there is some malicious intent, but just because human language, any language, is very far away from being clear and unambiguous. So that's one reason why what's documents is sometimes not understood by whoever read these documents. Yes, the other one is what is called the curse of knowledge. Curse of knowledge is a problem that, a mental problem that we have, that if we know something, if we understood something, if we internalize something, it becomes obvious to us. And then we have very hard time explaining it to other people because we assume that everybody else obviously know it. You know, you're full of you're a room of smart people. When I need to explain to you that language is ambiguous, I don't feel comfortable. I feel I'm explaining to you something that you obviously understand. But it is important to find this kind of knowledge, especially in documents that define software, for example, and then explain things over and over again to make sure that everyone understood. And this image is like, you know, you go to university and the professor starts with, hello, good morning, how was your weekend? And you're like, okay, I'm going to check my email real quick. And then you look up 30 seconds later and this is on the board. Because the professor sure that you already know all this because they know all this. So yes, so that's the curse of knowledge. All right, so why PRDs, software design documents, don't work? Human misunderstanding and curse of knowledge, that's one reason. Context is not shared enough. The context that product people have from the industry, from business people, from other sources, is not necessarily passed to developers. Yes, it should be written in those documents. Sometimes it's not, sometimes it's just boring to read, so I'll stick to what I need to do without reading the context, and this affects how I'm going to implement it, and further responsibility boundaries. Blame game. Do you remember this period in time? That was like a big deal like 20 years ago, 15 years ago. Who still thinks that's the case? Yeah, no one, me too, because this was just stupid, frankly. Testers and QA people are, for us developers, on our side. They help us writing better software. They are amazing. Thanks to them, we love them. Remember this? This is like your 15, 10 years ago, throwing over the fence, software over the fence, silos and what's not. This was fixed. How did we fix it? DevOps, of course, DevOps. Right, DevOps fixes exactly that. And you might or might not practice DevOps as you should, but the solution is out there. This is a real problem. And this problem is live and real. When the software is not great, whose fault is that? Did the product people not define software as they should have in the PRDs and so? Yes. Or the developer wouldn't code what they have asked to. Never. Right? So this is very real. And this means that we have a problem, trust problem, not only with AI. We have a trust problem in the industry. And the next thing we have this Venn diagram. That's my favorite Venn diagram of all time, by the way. You can relate, think about it, the software that you like, and then you learn about it, and then you don't like it so much. This is it. Because software is terrible. I have an entire talk about that. Oh, but hey, sometimes software work, right? Sometimes we manage to do things right. I mean, we can read email, unless it's Outlook, but yeah, sometimes it works. So why? There are a couple of reasons. First of all, both people, business people, developers, they are there to do their work well enough. And no one wants to sabotage what they are doing. So there are good intentions. Professionalism, mastery is one of the most important things for our self-esteem. When the developers want to write good code, we will make an effort. Personally, as we mentioned, amazing people help us with the software, capture a lot of those misunderstandings and briefs and puzzle things that go between us and the product people. But at the end of the day, we run the code, we look at it, and we see that the button is misplaced. So we go and fix it, hopefully. And at the end of the day, this context is not shared enough, but it's shared mostly. We know that we are working with a new client. We understand what a new client is. Even if we didn't read this software definition document to the bot, we understand what we need to do. Now, it's fine. There is no intention because it's a stupid model. There is no professionalism, it's a stupid model. test and QA, we trust the same model to do tests for wrote the code, that. It cannot look at the page and say that the bottom is incorrect. There is no context at all. So everything that can hold our terrible software industry by the string is there is absolutely nothing that can hold software. It's terrible. And the last point is the most important. There is absolutely no context when it comes to AI model. AI models are very smart, but they're very stupid. So this chasm between what the user asks and what the model understands is really profound. This is not a real example, but you can get the gist. How do I use Spring Boot? Well, Spring is a season of a year. You cannot really bootstrap a season of a year. It doesn't make any sense. Well, it actually now knows what Spring Boot is. The more it learns, the better it becomes. But it's very far away from actually understanding what we know, especially when we are defining a new software. But it gets worse. LLMs, by definition, are non-deterministic stochastic models, which basically means that they will give you a slightly different result every time you ask the same question. And this is by design. And you cannot turn it off. And it's absolutely fine when you ask about what castles should you visit in Scotland, because it will probably be the same list phrased differently, or it might be a slightly different list, but since they're all amazing castles, you won't notice any difference. But when it writes code, it's the difference between it compiles and it almost compiles. This reminds me of the infinite monkeys theorem, and you probably know it. Given infinite time, if you give infinite numbers of monkeys, infinite number of typewriters, eventually they will write Shakespeare. What does make sense? AI LLM models are those monkeys. We give them GPUs instead of typewriters, and they are doing slightly better than complete random, but it's exactly that. Sometimes they will output code that is perfect and compiles and does exactly what we want. Sometimes it will look like Shakespeare, but it will be Shakespeare-ish. There will be some slight differences here and there, which are obviously absolutely critical when we are talking about software. So basically, what can possibly go wrong with AI-generated code? And then I hear, it's fine, we have code reviews. We're going to read all the code that AI generated, 25,000 that it generated just last night, line by line, and then we're going to make sure that it's Shakespeare, that it's perfect. Well, I have bad news for you. Not going to happen. This is called the looks good to me syndrome. And it works like that. We are actually busy with other stuff. And we don't like reading code. We don't like reading other people's code, which includes our code for system failure. And we definitely don't want to read AI-generated code. Therefore, looks good to me. So yes, we have a huge problem with AI-generated code. But good news, it looks like the industry found the solution. And the solution is, who can guess? AI code reviews. Well, AI checks AI code doesn't sound very good to me. Spec it? Exactly, spec-driven development. Spec-driven development, and spec it is right there, is a new development paradigm that is now all the rage. Who attended Arun Gupta yesterday's talk? Half of you at least. So you heard Arun going for 90 minutes about how he does barbecue and writes code with spec-driven development. And so Martin Fowler was talking about it, or ThoughtWorks were talking about it. There are frameworks like Spec from GitHub, from Microsoft, OpenSpec, which is also like very hype now. Amazon releases the entire IDE for spec-driven development. They have a booth downstairs. Go check them out. Kiro is absolutely awesome. Zenko have an entire, not even IDE, an entire desktop tool that does spec-driven development. And the same one of all AI LLM coding American Party is talking about spec-driven development element. Spec-driven development is all the rage. And obviously, as I mentioned, our here in the conference had a full keynote room, people fascinated with spec-driven development. It looks like we are bridging the protocol problem. And how does it work? Very simple. We have the documents that the project people and the business people write. And then LLM creates what we call specs. And those specs are how the models understood the documents. We read the specs, they are still like human readable, and we say, oh, we skipped this paragraph, you understood this one wrong, we actually made poison and not marriage or whatever makes sense, right? And everybody read the spec until they approve it, and then LLM writes the code. Because now we are sure that LLM has the correct context and the correct spec. Problem solved? Well, yes, but no. We didn't close the chasm. We got 3/4 of the way there, and then we pretend that there is huge piece that we didn't solve, but we won't look at it. And this is the implementation part. So yes, we have a spec that we agree, but who decided and how do we know that the code that the model writes will be correct? We can ask politely, make no mistakes. Will it help? Probably not, because stupid monkeys. Sometimes they will do what is in spec. Most of the time they will do almost what's in the spec, close enough to what's in the spec to fool us, because we are not going to read code, looks good to me, but the code looks solid. There is 25,000 of lines with 286 tests. All of them pass, and 95.2% test coverage. This is good code. It's not. One rule that you need to remember from this presentation is never trust a monkey. Let's review how spec-driven development works and critically assess what can we trust. So here we go. We have an artifact, which is a prompt. This is this software definition document written by people. If it's written by people, which are sort of monkeys, we shouldn't trust it, because never trust a monkey. And when there is spec generated by the monkeys, shouldn't be trusted. And then there is code generated by the monkeys, shouldn't be trusted. Do we solve the problem? Not really. Not really. Now, we have some way to verify what people say. This is President Reagan, and this is President Gorbachev. And here is 1988, if I remember correctly. The point is excellent, and those are negotiations about nuclear disarmament. And both of them say, yes, trust me, bro. And then Reagan actually quotes an old Russian proverb, "Доверяй, но проверяй," which in English means trust but verify. We can actually go and verify what the partner that we don't really trust does. Let's see, how can we verify the spec-driven development? So, prompts, software-defined documents, can be verified by other humans. We can read the document and kind of highlight parts that are not clear, that are wrong, and say, hey, this is not great. We can do this with spec, because spec is still human language, and we can read it and say, hey, you got this wrong, and you got this right. Now, code, not going to be verified. That is the chasm that is still there, and it's still right. Great. I mean, if to actually ensure that the code does what we expect it to do, tests. What the of course, tests are the business for monkeys. That is perfect. How do you do that? Well, write tests first. Let the monkeys do the code. And then, if the tests pass, then our intent is captured correctly. Looks familiar to anyone? How does it look like? TDD, of course. This is TDD. This is excellent. What do we have here? We have now tests that are written by monkeys, because we're not going to write tests, and then verified by humans. We can retest. And then we have code, which is, again, written by monkeys and verified by tests. Looks nice? Okay. So I mentioned that someone actually needs to write those tests and then read those tests. Ideally, who has the intent in their hand? Product people and business people. If we go to product people and ask them to write tests, what the answer will be? Yes. What are they going to do? Not going to do it because it's not their job, because they're not technical, and generally because, like, we write the codes. And the developers end up writing the tests, and then writing the code for the test. Who practices TDD? 1, 2, 3, 4, 5, less than 10 people in the room, and some of them did this, which I can relate, and the rest of you don't. But, okay, let's start with another question. Who knows what TDD is? Everybody. Who believes it's good? Same hands. And who practices like 10 people? These are based for action. When we're given a problem, what are we thinking about? Okay, how are we going to write tests for it, right? That's the first thing that comes to mind. Oh, and corner cases. Yes, let's think about the exception. Sure. What we think about is, let me code this real quick and see that it works. This is what we want to do. We are going to solve the problem. And if we want the tests, it sounds like a good idea. We want to read the tests, and if we want to code, we're sure not going to read tests. It's more boring. So, this is even worse. Now there are two parts of our chain, of our process, that are left to looks good to me, and we're not going to read it. And remember, never trust a monkey. So let me restate the problem. We need to verify tests somehow and verify code somehow. This is what we end up with. Now, let's look at what tests are and pay attention to what really matters. Or set up, like if I'm a Spring developer, I'm going to instantiate my context here, and then a bunch of mocks and stubs that we set up. We might bring some Spring beans, some real one if it's an integration test, some mock ones if it's and we need to set up access. Oh, I need to test a private field here. Should I expose the data? No, I don't want to. I can do something dirty in tests, maybe access a private field. Fine. And then the function. The question is, Jane really has $5 as expected. This is the money, $5 money. This is the money shot, as they say in the movies. This is what we really care about. So what we need to do, we only need verify assertions. Now, with assertions, what comes to mind? This. Given, when, then. And the year is 2013. And talks about given, when, then as a style of representing text. From this article, it goes like we have a user story, the user trades stocks, and then there is given I have 100 shares, and I have 150 shares, and the time before closing the trading, when I ask to sell 20 shares, then I should have the end result. This is an assertion, and it looks like specs. It looks like specs in another concept called BDD. Who heard about BDD? Most of you. BDD is about defining those kind of specs, and then we generate the tests that use those assertions. Now, we're back to the definition. Who writes the specs? The whole idea of BDD and given and then specs is that they are always plain text. Which somehow, 50 years ago, the product people, if you ask nicely, are going to write their requirements in the format that we can actually learn. Who practices BDD? Well, 3 people, 4 people, and some of them are okay. Why don't you write it in the format that is good for us because it's like we can work with it? Go to a painter and tell them how to paint the picture. This is me. I'm writing PRDs, software design documents, a beautiful design. I cannot be bothered with this bullshit. If the get like to do because we need to write tests, immediately we're going to write specs. Right? Because it combines 2 very important traits. It's human readable, but it's also machine parsable. We can generate tests from those specs using a tool, using code, using algorithm. And this means we don't have to use monkeys. Deterministic algorithms will give us the same result every time we ask. It will be Shakespeare over and over again. So if we can replace monkeys with machines, we are in a much better state when it comes to deterministic results. So if we can do that, we will verify another step in our chain. The prompt is verified by humans, the spec is verified by humans, and now the tests will be created by the machines from the specs and verified by the machines because there are no monkeys involved. This is great. Now we need to make sure that the code adheres to tests. What is the problem? The problem is circular verification. Remember what was that? The same model that wrote the code decided the code doesn't work. And instead of fixing it, commented out the test. Because it was easier. Remember, for simplicity, true equals true for simplicity. How can we prevent it? The first idea that comes to mind is just make the test read-only. If we make the test read-only, the monkeys cannot tamper with it, and then we will have to write the code until they actually solve the problem, because in the end of the day, we need to see like a build and test the stuff. Problem solved? Well, here's the next one. Going back to this slide. All the steps, the first steps, we will usually figure out after the code is written. When we talk about TDD, test-driven development, and writing tests before code, what we actually say is we write assertions before code. It's almost impossible to write tests before code for something more complex. Because all those items, which mock do I need? Which step do I need? How do I set up the test? We can only figure out after the code is written. Because we don't know the names of the methods and the fields. We don't know how the code exactly will be looked and how we should test it. The only thing that is defined up front are the functions with the format of given and then, obviously. So what we need to lock are only the functions. Now, how can we do that? We cannot like use read-only files because the test file contains all that. But since the assertions are text, we can save the text. The easiest way to save the text is to hash it. We can take a hash code of the assertion and save it away from the dirty hands of monkeys. For example, we can put like LLM should go to really length. Easier just to do the right thing. So we can store it in a commit, and then after the tests are completed, make sure that the assertions in the tests and then is actually verified by an algorithm of comparing the hashes. We solve the problem. We build what I call intent integrity chain. So everybody expects everybody read the stack. And then algorithm text. And then the text, verifying the assertions until they are passed. Because when we write text, specs are readable because they are human readable. And although product people won't write the specs, they will agree to read the spec. And then specs or leaving documentation. They will also always be up to date. And then everything else derived from the specs and all the code is verified by the machine. That was a great idea and never picked up. We defined and code. And then we cannot verify. There is not a part of this chain that we just trust. Problem solved. But very close. Very close. The only problem left to solve is what if they really don't know what to do. Start with warnings that the really pain. Really please. Start with explaining like that we do with Victor Gamma smart bulb, who attended our deep dive on Monday. A couple of people, you saw that. We turn on the light bulb using AI generated code. It uses some obscure library that the models don't know about. So if we just ask to do it, if we don't do it will just blow over the world. But it cannot stop until the tests are passed. It cannot tamper with tests because we locked the assertions, and it genuinely doesn't know what to do. It's going to invoke API after API after API. Before. And obviously another example is the corporate clause libraries that obviously models have no idea about because they were developed in-house in our company and only used in our company and no one else knows about. So what can be those solutions for that? So programming data works until it doesn't. it's going to get to be great with a popular version of React. It probably won't be great with the latest version of Spring Boot or of Spring API. It can hold on. The model cannot search anything. The model is just like a huge text file. But the agents actually know how to get online and search for stuff. It will find all the wrong answers on Stack Overflow, and it will find blogs that claim incorrect claims, paywalls on Medium, stuff. We can really get on and build custom RAG pipelines that will bring the information in. It will cost us tons of money, and depends how much one can do. Or you can ask the model to read the manual. How can we use the model to read the manual? We can provide it with the relevant context using tools like Tessel. And thank Tessel for paying for me being here. So what Tessel does, what do we do, is we provide LLMs with quality context. This is an example of Spring Boot of the latest version, and what you can see here is what we call an eval, a review score. You can see here results of how good this piece of content is based on was it a good piece of content as designed, was it implemented correctly, and most importantly, the activation score is how consistently the model asks for this information instead of hallucinating. So this is kind of the eval. And we do it for APIs, API docs, for what is called skills. Do we know, teaching an agent to code in a certain way or using a certain library, or steering code styles, corporate standards, use this instead of that, this kind of stuff. And this is loaded in real time when it's needed, and it closes the last piece. And here we have it. The full intent integrity chain generates consensus. Features are verifiable back to the requirements always, right? Because the spec is tied to the requirement, code is tied to spec, and we can start trusting AI-generated code. Obviously, in order for it to work, context management is a must. This won't work without giving the model the right context. That was awesome. This is where I finish, but you asked me a question, how is it actually implemented? Is there something that we can start doing tomorrow? What day is tomorrow? Probably Monday, but okay. Remember Spec Kit? It's one of my favorite spec-driven development kits, but as you remember, it has the trust me bro part of generating code. So I forked it, and we created Intent Integrity Kit. And you know where you can find it? Right here. Intent Integrity Kit does what Spec Kit does, but it adds the part in which we generate the tests from the spec and we log the assertions. It adds the part when the model is going to go and bring all the context that it needed every time there is something about code. And it adds the part when in the end of coding we will check that the assertions are actually the same assertions that we were asked. So this is a real-world implementation of integrity chain that you can try today and probably feel a lot of bugs because it was all obviously AI generated. But I did dogfooding, I did it with integrity chain, so maybe not that many bugs. With that, this is where you scan to give me 5 stars. The whole system was wipe coded, so everything except 5 stars doesn't work. It will crash your computer and you won't be able to use it again, so don't even try. At JBaruch everywhere. Talk to me about Tessel, I'm here around. JFokus is the hashtag that is trending for the conference. Intent Integrity Chain, I'm going to check in 2 hours that it's trending as well. And speaking.jbaruch for the slides, the links, the video that I'm going to upload in right now after the talk. Thank you very much. We actually have perfect 5 minutes for questions. Any questions?
I have one on here.
Yes.
So, how do you get the algorithm that sort of derives the tests? Where's that out?
Where is the algorithm that derives the tests? Now, that's a great question. And this algorithm exists for 20 years by now. This is a part of behavior-driven development. There are a lot of different tools for a lot of different languages. The most well-known is called Cucumber. It has implementation in Java and also other languages as well. What it does, it actually converts the specs into kind of a templates for tests in which we already have the assertions which exactly match the spec, and then we just need to do the rest of the stuff, which is like mocking, stubbing, and bringing the right pieces. There are also others. More questions? Yes?
What's the difference between spec-driven development and waterfall?
I love this question. What's the question between spec-driven development and waterfall? Spec-driven development feels like waterfall. It feels like a kind of heavy enterprise a structure that we go through all the design steps before we actually write the code, and we obviously hate waterfall with passion for very good reasons. By the way, what are those reasons exactly? I remember. Those reasons are that we kind of plan for a year and then implement for 5 years, and then in the end check that everything is wrong. Because both we didn't understand what people asked and because the requirements changed. Now, this is not what's happening. Yes, we have a process, but process wasn't the waterfall problem. The problem was lack of context sharing and intent integrity, and the problem was that we discovered it 6 years later. Both of them are not true for intent integrity chain. We know that we, if in the end of the day, get exactly what has been asked because we verified our intent, and it's going to happen in 2 hours and not in 6 years. And we break our software to the smallest components possible because we want those chains to be small. And we want it for a couple of reasons. The first is we want it to be done in 2 hours and not 6 years. The second is LLMs have a limited capacity to understanding the context window. So the smallest the spec is, the better the LLM memory will be used, the more efficiently. And we want the code to be completely disposable. We didn't speak about any programming languages today. The framework couldn't care less. The spec is a language. The code is an implementation detail. The code is exactly what bytecode is today. It's an intermediate language that we can always throw away and rewrite. And you remember, the models are always getting better. The code that we will write 6 months from now will be significantly better than the code we write today. So how about we take our spec that we defined, run the intent integrity chain once again, and generate code in you. Will it be faster? Yes. Better, more secure, whatever you name it. Make yourself a cron expression to regenerate all your software every 6 months, and you will get significantly better software every write. This is nothing like waterfall. Couple more, I guess. Yes?
So, how do you bridge the gap between, BDD was on quite a high level, whereas if you write unit tests, you attend to the teeny tiny details of checking boundary conditions, all the tiny stuff, all the tacit knowledge that a developer is kind of expected to have. How does that?
This is a very good question. So the question is, BDD, it's more about end-to-end tests. The scenarios are on a product level and not on the code level. But we also want unit tests because we know that unit tests are good to verifying software quality. Now, this brings me to one of the most, how do I say it, like, epiphany professional career, where a friend of mine asked me, what is quality? And I'm like, yeah, that's right, and he's like, just keep asking, what's quality? Until I got it. The only quality that matters is what the person who is using the software is saying. We couldn't care less about the quality of the code unless it directly affects their experience. Well, how is it related to what we are doing? To the answer to the previous question, I couldn't care less about the code or its quality. The test that I really care about, and the test that we spoke today, are end-to-end tests, the ones that are derived from specs. Unit tests, the model decides to write them, fine. The model wants to write them, whatever. If the end-to-end tests pass, and if the requirements function, stuff like how fast the application is, how secure the application is, performing the role, whatever you need to define, and in specs, those requirements pass, I'm really going to care about unit tests. Whether they're unit tests or not, I don't know. Do I care about it? I don't. So yeah, probably the model will do unit tests because it's trained. But it really doesn't matter. What really is the quality that is defined in the specs, because this is what reviewers are going to interact with. And I think we're out of time. Thank you very much again. And here's all the good stuff.